Hello and welcome back to my workshop for another of my little Jeti training videos, and in this one we're going to look at how you can get audio tones from the Jeti MSpeed airspeed sensor in such a way that it could help you fly the model within a particular speed bracket. For example, when you're coming into land, helping you fly at a particular approach speed, or a little range of approach speed anyway, and warning you from the audio tones if you're starting to get too slow or starting to get too fast. And I've rigged up a little way of simulating the airspeed over the MSpeed sensor. Here we have our MSpeed sensor installed in one of my Nimbus gliders. What a lovely thing to say, one of my Nimbus gliders. I have two of them. And there's the little air pipe comes down to a syringe that I'm going to use to pump up the air a little bit. But airspeed sensor is a very sensitive little pressure instrument, so we have a tank here to help absorb the increase in the pressure from the syringe. The system is so sensitive that if we've got an airspeed of 0 and I do that with the tank, within about 2 seconds it'll be recording 60 miles an hour, because that alone is enough to heat up the air in the tank enough to really blast the airspeed up. So we have to be very careful. Now look, there it is, it's cooling down. See, those just touching the tank, it's cooling down now, so the air's shrinking and it's dropping. I'll just disconnect the syringe. There we go. So that's zeroed the system out. Okay, put it back in, and if I give the syringe a little bit of a pump, we can see the system tends to come alive at about 25-28 miles an hour. Below that it just can't record anything. As I pump the syringe up, we can get higher and higher speeds. Okay, I'll bring the syringe back out. Just disconnect it so I'm not giving negative pressure. Reconnect it, and off we go. Okay, and to get these rising tones we're going to use the Vario software. The Vario software is quite decent. You can use it with all sorts of sensors. So let's have a look. Timer sensors, Vario mode, the EX value, which will be coming from the MSpeed, and we'll enable it, and off we go. Now, you don't want this running through the whole flight, so I would suggest you assign a switch to it. Here, it could be, for instance, just simply the retract switch, but you probably don't want this running whilst you're, setting up for and taxiing out and taking off. So maybe it'd be better to create a logical switch using wheels down and full flaps, or wheels down and takeoff or landing flap, and assign that as the switch so that it only comes alive at that particular point in the flight when you want it to. Okay, and then we come down to the EX parameter, and it lists here any telemetry that it's getting through the system. I'm using a assist receiver, which is why it's giving you some of the assist stuff, but here we are at velocity meters per second. There we go. I'll turn the volume off for the moment. Now, being British, my brain works in miles per hour, and that's what we've got set in sensors logging setup. Come down here, MSpeed I've chosen miles per hour, and that's therefore what it shows on the front screen in display telemetry. But sadly, when you choose the Vario software, it just wants to work in meters per second. So we have to do some conversions here. And so we'll be looking for finding 5 values. The dead zone, minus and plus, and the range. So the center of the range, and it's the maximum and minimum points of the noises it's going to make. So what do these actually mean? Well, what we're going to do is we're going to choose our landing approach speed, which you would have worked out previously from flying the model and recording or getting it to speak the actual speed when you're on the approach, and you've determined that. So what we'll put in here is your ideal approach speed. They will then create a dead zone of plus and minus from that approach speed, which is where you want the system just to be quiet. In other words, if you're not hearing anything, you're within that range of speeds that you've chosen to be your approach speed. And I would suggest you don't try and make this too tight. I think if you've got plus and minus like 1 mile an hour or 1 kilometer an hour, you're just never going to get in there. It's just too tight. Models can accelerate and decelerate too rapidly. So I'm going to choose an approach speed of 50 miles an hour, and I'm going to choose a dead zone of plus and minus 5 miles an hour. What then is the rest of the range? Well, the range determines the speed at which the tones will reach their maximum. So if we choose, say, 60 miles an hour to be the top of there, then it means that once you got to the speed of 60 miles an hour, it'll have reached its maximum beeping, and any higher speed, it'll just carry on at the maximum beeping. And the same with the bottom of the range. If we choose 40 miles an hour, it'll reach the lowest of its tones going downwards at 40, and then any speed below that would just be tone. So in a sense, it's how sensitive the rising or falling tones are to the changes in speed. So we need to work out what is meters per second compared to miles per hour. So I've just Googled, convert my various speeds. So here we are. Here's my speeds laid out rather as they are on the transmitter screen. I'm aiming for 50 miles an hour as the center of my range. I'm going to 60 miles an hour as the top of the range, 40 miles an hour as the bottom of the range, and I'm going to have a dead zone of minus to plus 5. And Google tells me that in meters per second, that's going to be 22.4 meters per second is my chosen approach speed. I'm going plus or minus 2.2 meters per second. And the range will be 40 miles an hour is 17.9 and 60 miles an hour is 26.8 meters per second. But if we put in 26.8 as the top of the range, or say 60 miles an hour, it won't actually count that as the top of the range. It will count it as the speed we've chosen there plus the dead zone. And similarly around here, it'll choose that speed minus the dead zone. So we just have to deduct it. So we're aiming for 60 miles an hour, which is 26.8 meters a second. And if we put that in, it won't actually reach the top of its beeping noises until we've got 26.8 plus 2.2. So we need to deduct it, 2.2, from the 26.8, which gives us 24.6. Similarly, at the other end, if we put in 20.1, it will then knock the dead zone off, so it won't reach its beeping until we've lowest tone until we got down to 17.9. So there's the figures we want to put in, and we'll see how it works. So I'll just come down and I'll put them in. Remember, it's meters per second, so we're looking for minus 2.2, which is minus 5 miles an hour. Come here, plus 2.2. Okay, and come down. And the range was going to be, what did I say, 20.1. This is a case of making use of your stepping. Oh. 20.1. Come to here. I say use the stepping because each click of the wheel is 0.1, so it can take a while to get anywhere. So if you press the menu button, you can get ones, tens, 0.1s, ones. So we'll go with ones for the moment. I'm going to get down to about 22. Point back to 0.1s, 22.4. There's my chosen approach speed. And this one, I want it 24.6. 24.6. There we go. Now it's all set up. Here is showing the actual speed, 0 meters per second. I've got the volume turned off at the moment. I'll just gently press the syringe. We'll see the airspeed coming up. There we go. Whoop, way up there. So this is compared to the chosen neutral point and coming down again. Okie doke. And what's gone wrong there is I've managed to set that somehow got altered. 22.4. Probably me escaping out of it without centering it. There we are. Okay. So I've got my settings all in place. No, 20.1 that should have been. 22.4, 24.6, and where am I? Right. Let's go and see what happens. I'll bring the volume up. I'll get it to about 50 miles an hour. It's in the bracket there. Right. Got the volume up. And we're in the bracket of 50 miles an hour plus or minus 5 miles an hour. So the system's being quiet at the moment. If it drops below 40, there we go, drop below 45, we'll now get falling tones. And there we are, at the chosen 40 miles an hour, it's reached the lowest tone it'll make, and any lower speed just carries on with that tone. Let's speed up, because we're going a bit slow. At 45 it'll go quiet. Right, I'm happy. And it'll be quiet all the way up to 55. And then as we go above 55 miles an hour, it'll start the beep, beep, beep to tell us we're too fast. And there we go, at our chosen 60 it reaches maximum beeping. Come back down into the zone. There we are. Now it's up to you to choose the numbers. You might find that that's a total 10 mile an hour bracket, plus or minus 5 either side. That might be too wide. Or you might think, well, I don't mind being a bit over speed, so I'll choose plus 5, but under speed I don't like, I'll just choose minus a couple of miles an hour. It's entirely up to you. But this is how you get the system set up like that. So if that's how you'd like to give it a try, go on, give it a go, and I'll see you for episode 2, in which we'll use a different way of doing it. Oh, be quiet, you. With a Lua script. Bye for now.